In example 2, we just found probabilities using the binomial distribution by reading the graph, adding up those values, but that can be a little tedious and time-consuming. So what we want to do is look at how we can use technology to find those results for us, using that exact same process, constructing that graph, and then identifying which values we want to consider as successes. In example 3, we want to find the probability of drawing from a standard deck 14 times. So that's going to be a key value. That's our number of trials. These are occurring with replacement, which is important so that each time we draw a card, we're not changing the number of cards in the deck. We're replacing that card. And we want to get exactly 5 hearts. So that 5 hearts that we're looking at, that is the number, that's our success. What we need to do then is determine the probability of drawing a heart, which in this case would be 13 out of 52. Switching over to Desmos, we're going to pull up a command for the binomial distribution. There are 2 ways to do this. You can literally type it in, or if you click on this keyboard option and then click on functions, there will be a section if you scroll down called distributions. We want to click on binomial distribution. Then you can hide that keyboard. We need to type in 2 values, the number of trials, so in this case 14, and then a comma to separate the success probability, in this case the probability of drawing a heart, which is 13 out of 52. A little magnifying glass with a plus will show up. That'll give us a zoom fit option. So if we click on that, it'll just change the boundaries of our window so we see our distribution more clearly. In this case, we want to find the probability of getting exactly 5 successes. So we can find where x equals 5 and click on that point, and it'll give us that corresponding probability, which in this case is 0.1468. So this was the probability that x is exactly equal to 5. In example 4, we're changing our number of trials, still selecting with replacement. We want to find the probability of getting 4 or fewer numbered cards. That's going to be the probability that x is less than or equal to 4, and we need the probability of getting a numbered card, which will be 36 out of 52. Flipping back to Desmos, we'll change our number of trials to, in this case, be 12. Our probability of success is now 36 out of 52. And what we want to do is calculate a probability with an inequality statement. So we'll check this box to find a cumulative probability. That gives us a field to enter a minimum and a maximum value. In this case, we want x to be less than 4, so we'll only plug in a maximum value of 4. And that result, you can see which dots are highlighted on the graph, is finding the probability of 4, 3, 2, 1, or 0 numbered cards, which is 0.0112. And just a minor thing, let me go back to say that that probability we found in example 3 is also an approximate. And then we can keep doing this with new values. We just need to focus on what that probability statement is in each problem. So in this case, we want the probability of getting more than 4, but fewer than 8 face cards. So that means we want our number of face cards to be more than 4, and less than 8, and we need the probability of getting a face card, which is 12 out of 52. Before we flip over to Desmos, though, it's going to be important for us to modify this inequality statement. When we enter those upper and lower bounds, Desmos is always including the value at each end. So this is the same thing as the probability that 5 is less than or equal to x is less than or equal to 7. Our probability statement always needs to be inclusive of both the top and bottom ends. So we'll change our number of trials. We're back to 14. Our probability of success is 12. And now we need to enter both a minimum and a maximum value, which in this case would be 5 and 7. And we can see 5, 6, and 7 are highlighted. Those are the probabilities it's focusing on. That probability is going to be 0.1982. In example 6, we want the probability of getting more than 3 numbered cards. That would be the probability that x is greater than 3. Which would be the same thing as saying that the probability that x is greater than or equal to 4. We always need to make that adjustment. And then how many ways we can get number cards. The probability would be 36 out of 52. So still out of 14 trials, our probability of success is changing and our minimum and maximum are changing. In this case, we have a minimum of 4 with no maximum. So anything larger than that would be a success. And in this case, we get 0.9996837 and on. Our typical rounding rules would have this value round up to 1, which is no good because if a probability is equal to 1, that means it's absolutely going to happen. There's no way it won't happen. So what we want to do is report this as greater than 0.9999. If we rounded that up to 1, we would be eliminating the possibility that it can't happen, which there is a very, very small possibility. So we're just going to add that statement, greater than 0.9999, to avoid rounding that up to 1. In example 7, we want to find the probability of drawing from a standard deck 75 times with replacement. And we're drawing face cards, so our probability of success is 12 out of 52, and we want between 1 and 3, including 1 and 3. So our probability of success in this case would be 0.000005, a value that would typically round to 0. But we don't want to round that to 0 because, again, in this case, that would mean that the probability of getting between 1 and 3 face cards is impossible, is absolutely 0. So to avoid that, we're going to say less than 0.0001. So it's a very, very small probability, but it's not quite 0. In example 8, we want to find the probability of getting fewer than 10 number cards. So that's the same thing as saying the probability that x is less than or equal to 9, with, again, 14 trials. Or I guess now we're changing that back to 14 trials. And our probability of success is 36 out of 52 for the number cards. We'll get rid of that minimum, but our maximum is 9 because we want 9 or fewer. And we get a probability of 0.441. In our last example, we want to find the probability of drawing from a standard deck 29 times and getting 4 or more spades. So that would be the probability that x is greater than 4 So now we have 29 trials. A success is getting a spade. That probability of success is 13 out of 52, and we want 4 or more. So we have a probability of 0.9545.